Okay, thanks so much for your question. I think this is a really good example of how to work through inductive proofs. So yeah, I'm really keen to show you how to solve this one. I've already started by doing the first step, which is just to prove the n equals 1 term, the first term in sequence. And what's important here is that you actually show this left-hand side equals right-hand side dynamic. Even though it's usually obvious, you're required to in terms of it being a proof. But what I'll get to now is the inductive step. So step 2, sorry, not the inductive step, this is the inductive hypothesis. So we're saying that if n equals some value k, where k is a natural number here, then same kind of thing, that plus that plus all the terms in the middle. Now we're up to some other term. So we know it's true for n equals 1. We need to prove that it's true for some number n. We're using a different number here, k, first of all. All the way up to k plus 1. And that equals 1 minus. And so we can assume that this is true. And this is the assumption here in mathematical induction. Okay, so now step 3, and the most, I guess, involved step is the inductive step. And so what are we required to prove? If it's true for some number, so we're saying, okay, we're assuming it's true for a number, right? If it's true for all numbers, it has to be true for any number plus the number after it. And so what we need to prove is, okay, does this hold for the term we just assumed was true and the term after it? Illustrated by k plus 1. So we get something that looks like that. And on the right hand side, it has to equal 1 over k plus 1 plus 1. Okay. If we start on the, oh, actually, I'm just going to start by, okay, it's pretty straightforward, so I'm just going to simplify this down. This is k plus 2. This is then k plus 2 in here as well. That's the only change I'll make before we actually get into the proper proof. Alrighty. So on our left-hand side, if we start there, we've got a whole group of terms, but importantly, we've got this sequence, which is the same sequence as found in the assumption step, which means instead of having this, we can transfer it into just being this on the right. And so that's what I'll do here. That has to then equal 1 minus 1 over k plus 1 plus our new term. K plus 2. And the strategy we're going to use here, and what you'll find is a pretty typical approach in induction problems, is we want to find a common denominator. And so it seems kind of silly, but we actually want to get everything to this, because we take, okay, what's the hardest one to get, and we then can work from there. And so let's do that. So instead of being 1, it's going to be k plus 1 times k plus 2 over k plus 1 times k plus 2. We've already got a k plus 1 term, so we need to multiply that on the bottom by a k plus 2 term. If we multiply that by k plus 2, we've got to then add a k plus 2 on the top. And I'm just being extra careful here and putting everything in brackets. And then this one is all good, as is. All right. So now what I would like to do here is actually condense them all into one kind of string on the top. So that will look like k plus 1 times k plus 2, and then minus k plus 2 plus 1, and all of that is over k plus 1 times k plus 2. All right, so now we've got to go to work here with what we have on the top. And the easiest place to start is probably going to be by expanding out this term here. And that will give us, do it in a different color. So k squared plus k plus 2k plus 2. And then we've got, and I'm got to expand this out into the brackets, minus k minus 2 plus 1. And then all over still what we had on the bottom before. K plus 2. Cool. All right. So now this is actually k squared plus 3k. However, can you see that these two will cancel? Similarly, these two will cancel. So actually, all I've got on the top there is just k squared plus 2k plus 1 all over k plus 1 times k plus 2. We now want to factorize that quadratic. So our two terms have to multiply to equal 1, have to add together to equal 2. It's just going to be k plus 1 times k plus 1. Sorry. Like that. And so at this step, they're going to cancel out. And so we're just looking at k plus 1 over k plus 2. And you might think like, okay, that seems pretty simplified, but it's not actually what we've got over on the right-hand side. And you'd be right. I think the easiest way to reconcile this is then go over to the right-hand side, just really quickly, and get this into one fraction. So we've got 1 minus 1 over k plus 2. If we get this to a common denominator, that's going to be k plus 2 over k plus 2 minus 1 over k plus 2. That is k plus 2 minus 1 over k plus 2, which is k plus 1 over k plus 2, which equals our left-hand side. And then we can do our like hashtag QED if you want, and say that therefore by mathematical induction, P of n is true. And that's it there. Hope that's a helpful example. That's a really common type of induction problem, particularly when you've got that kind of string of summations and you've got to look at kind of creative ways of combining denominators and getting everything to a common denominator. Cool. So I hope that helps again. Feel free to leave any feedback below if you enjoyed. We really appreciate your support, and yeah, keep submitting some questions in. Hope that helps. Thanks.